basically? Or?
So the way we did this is actually pretty cool. In the new syntax for targeting .NET and C++, destructors are the same thing as dispose methods. So what we do is we implement, whenever you put something up, whenever you use a ref class as if it were a stack type, we end up generating code that actually looks kind of similar to what C# does for using blocks. Except you don't have to have a using block. You just do the declaration, use it at the end of the scope, it gets taken care of. You don't have to worry about the programming mistakes that people often make and don't do the using, or where people don't actually implement the dispose pattern correctly, because by having your C++ destructor, you automatically get the dispose pattern done right. One of the nice things about having that model, and one of the reasons we chose to go with that model instead of trying to do some custom CLR functionality, is that it's fully interoperable with what everybody else does. So if I implement a C++ type and I put a destructor on it, since that destructor just ends up being the dispose method, if I then use that type that I authored in C++ from C# and I put it in a pound using block, it works exactly as you expect it to work. The only downside to taking an approach like that is you don't actually get to reclaim your memory until the memory for that type gets GC'd. But what you really cared about was the resources, and those do get taken care of as soon as you exit the scope, just as you expected them to. One of the other kind of cool things about this deterministic finalization or deterministic cleanup, depending on how people like to call it, finalization in .NET is kind of an overloaded term, so sometimes we just call it deterministic cleanup when we're referring to .NET, is that you can use that in combination with templates in order to get some really interesting behavior. So one of the patterns that's very important to the C++ programmer is the smart pointer template. Well, when you're talking now about the .NET world, you're not dealing with handles so much as you're pointers so much as you're dealing with handles. So it would make a lot of sense to have a set of smart handle classes. And that's actually something that we have, a whole collection of smart handle templates that do things like auto close. So let's say, for example, I am using a stream that needs to get closed before you actually will call dispose on it or get rid of it. What you can do is always have a policy, and this is the way C++ programmers tend to write code anyway, where you say auto close, here's the type I want, it's on my IO stream, and then just declare it as if it's a stack variable. Use it as you always would, and then at the end of the scope, since we've got the deterministic cleanup, it goes ahead and calls the dispose not on the underlying type, but on the smart handle template. And the dispose for that smart handle template calls close and then disposes it. So you automatically get all your closes wired up, and you never have to worry about making a programming mistake there again. Just have the convention where you declare these things with the smart handles, and that's it. It's all taken care of for you automatically. So it's one of those things where any one of the features is kind of interesting, but then when you consider the power that you obtain by having these features interoperate with each other, that's when you get into some really interesting scenarios.
Certainly. Of course, you still have to know what needs to be cleaned up.
You do have to know what needs to be cleaned up. That's the type of thing that can be enforced statically using development policies. So it's not something that we have in Visual C++ 2005, but it's conceivable that in the future we could have support for specifically checking for these things using static analysis tools. If you define or declare a new stream somewhere in your C++ code, it's going to check and make sure that you did it the right way using this autoclose policy. And if you didn't, you're going to get an error statically without ever having to run into the problem after you ship the product, for example. We're making a lot of efforts in the static analysis space, and right now, even though they're really cool and they do catch a lot of errors, and we use them internally, and we're going to be shipping them as part of team systems, we know that we can do a lot more, and we're looking forward to doing a lot more.
So you think about that in the language design phase, about how to make static analysis tools more effective.
That's one of the many things we think about. If we have a good language design, it's going to be able to accommodate those things. We don't We don't think about just that, of course. What's really most important is making sure that the programming idioms that C++ developers have come to expect continue to hold true, and that's really what we focused on most, with keeping in mind a lot of these other things that were also important: cross-language interoperability, being able to do static analysis, being able to make sure that we can generate this code in a way that's high performance. Right? We actually put a fair bit of effort into making sure that these abstractions that you add by having deterministic cleanup and by having smart handles didn't add too much overhead. These are all things that we have to think about.